Okay, we're going to keep going with our logic and reasoning, and we're going to kind of bounce around between two sections in our textbook right now. So we're going to call this section 2.2/2.4, and this is going to be called deductive reasoning. Remember, we just talked about inductive reasoning. So for a refresher, inductive was when we use a pattern and we make an assumption. So deductive reasoning, we're going to define now. This is really more what you get into as an attorney. Okay, deductive reasoning. This is the process of using logic to draw conclusions from given facts definitions, and accepted properties. Let's see if I can squeeze that in there. Okay, the process of using logic to draw conclusions from given facts, definitions, and accepted properties. So remember, when we start talking about inductive versus deductive, okay, inductive, if we remember, is from the patterns that we see, right? And deductive is from the facts. Okay, so a quick example of inductive again would be our 1, 3, 5, 7, blank, blank. We're pretty sure that this is plus 2, plus 2, plus 2, so that would make this 9 and 11. That's a pattern we observed. A fact would be that 2 plus 2 equals 4. That's a fact. We don't make any assumptions there. There's no pattern to follow. You can do that with your fingers. I can get out popsicle sticks, lay them on the table, and you can count 2 of them, and you can count 2 more of them, and show me that there's 4 of them. And when you're trying to get proof, and you're trying to prove something is true, like say in a court case or in a trial, this is what you need. You've got to have facts. Okay, it's nice to say that, well, you know, this is what we see, so it looks like that's what's going to happen next. But if you can't get to this, you can't prove anything. You can't win a case as a lawyer. So we're going to talk about inductive and deductive a little bit, and we're going to write down some examples and decide if they're inductive or deductive. So here's our first one. A student is late to class every day. The teacher concludes the student will be late today. Teacher concludes the student will be late today. Okay, so when we read that, student is late to class every day. So that's saying Monday he was late, Tuesday he was late, Wednesday he was late, Thursday he was late. The teacher says, you know what, it's Friday, this kid's going to be late. Well, I hope that you can see that's a pattern. That's an inductive reasoning. There was a pattern there, right? The teacher said on Monday he was late. On Tuesday he was late. On Wednesday he was late. On Thursday the same kid was late. So when Friday comes around, what do you think the teacher's going to say? Well, she's going to say, this guy's going to be late again. But that's inductive reasoning. This teacher couldn't write this kid a detention before they were late, right? You couldn't say, well, you're late every day. You're going to be late Friday. Let me just get that detention filled out ahead of time. So that's why inductive reasoning isn't that good when you're trying to prove something. It's useful. It can help you get somewhere, but it's not going to win you any trials. Now, let's look at the next example, which you can probably guess what kind it's going to be. So if a student is late to class, they will be counted tardy. Okay? That's a fact. If a student is late to class, they will be counted tardy. Then, you were late. Well, when you're late, you conclude that you will be counted tardy. Right? And the same thing could go for something legal. It says, if you break this law, this is the punishment. Well, when you break that law, when you're late, it's pretty fair to say that you're going to face whatever that punishment is. And so this is an example of deductive reasoning. Remember, it's based on facts, right? All right, there's two types of deductive reasoning that we're going to focus on. The first one is called the law of detachment. And I want you to bear with me on these. They're a little different if you're not used to doing this before, but we're going to write this down and then we're going to talk about it. So the law of detachment says, if P implies Q is a true statement, and P is true, then Q is true. Okay, so just write it down. Write the little arrow. If P arrow Q is a true statement and P is true, then Q is true. Now, very important for us, the way that this P arrow Q is read is just like I said it the first time I said it. We say, if P implies Q, or we can just say P implies Q. Okay, we don't always have to have the if out in front there. You just see this, you can assume it says if P implies Q or P implies Q. Either way. So you want to put some bubbles around that or highlight it or something that helps you remember that, because this is going to come up a lot. These little P's and Q's, all they are is just like our example about the kid being late. So if you're late, P, you're tardy, Q. And so the law of detachment says, if P implies Q is a true statement, so if you're late, then you get counted tardy, right? So when it says P is true, that means you're late. Then Q is true. And that's kind of like saying, so you're tardy. Okay, so the P's and the Q's just represent the different events that happen. And when we say this statement, if P implies Q is a true statement and P is true, that means P happens, okay? You're late. Then Q is true. So true kind of means happens, if you can think about it that way. All right, we're going to write down an example of the law of detachment and how it works. So here's our example. So in geometry, you're going to see this a lot. You're going to be given information. Okay, so we're going to be given this statement. If a figure is a square, then it has 4 sides. Everybody would agree with that also, right? So if a figure is a square, then it has 4 sides. And now we're going to say, okay, A, B, C, D, those are 4 points, is a square. Fact, right? Because when it's given to you, You don't argue it. It's a fact. It's happening. It's true. So, if a figure is a square, P, it has 4 sides, Q. Our law of detachment says if P implies Q is a true statement, and P is true. So right here it says if a figure is a square, and it says A, B, C, D is a square. So P, true, right? Then our conclusion, which is what we write, is that A, B, C, D has 4 sides. And that is our Q. Does that make sense, hopefully? If not, we're going to practice it a lot, so don't worry about that. We're going to do one more law. This is called the law of syllogism. Law of syllogism. It's very similar with the P's and the Q's. It says if P implies Q and Q implies R are true statements, then P implies R is a true statement. And so that's basically saying if something implies something else is going to happen, and then that something else, the Q, leads to another thing happening, well, it's logical to say that if the first one happens, the last one's going to happen, right? So let's do a quick example. If a figure is a square, so we're going to be given this. Let's write given so we get used to that. Given. If a figure is a square, then it has 4 sides. Now we're going to have another statement. If a figure has 4 sides, then it is a quadrilateral. Okay? And we need to come up with a conclusion based on this statement, right? Using our deductive reasoning. Well, when we read through here, it says if a figure is a square. So figure is a square. That's our P. It has 4 sides. That's our Q. Then we read down here and it says if a figure has 4 sides. Well, that's our Q again. That's the same exact event, right? Then it is a quadrilateral, which is this whole new thing. So that's an R. So remember our pattern says if P implies Q and Q implies R, then PR is true. So our conclusion would be if P, then R. P implies R. So we're going to write if a figure is a square, then it is a quadrilateral. Okay, and that is an example of the law of syllogism. So that was our P, that was our R, and that's it.